So these are simple encryptions that I've done using sorry. So I've actually used this library called Crypto. So Crypto. Okay. Yeah, so this is a simple application. I've used this library. It's a JavaScript library that you can use it on. This is just a normal web 2 application. It's an application for delivery services, and yeah. So crypto offers a secure hash algorithm one. So this is the type that I'm using, and then I'm adding something called salt. Salt is a generated UUID. It's a random generated ID. Basically, it looks like this. It's a long text. So what I've done here is that I've created a function, this one called encrypt password. And generally what I'm doing in this particular function, I'm passing password as the variable or the plain text that the user enters. This is actually an input that the user inputs. So it's a parameter, and then I'm hashing that password using the header decimals. So normally how data is transmitted in computers, it's transferred in ones and zeros, and in binary format. And then you have other letters, because you have other letters which are included. That is the octo, which is 8, and then we have the decimal, like what we saw yesterday. Yeah. So then there is another function here. This this other function, the authenticate function, it's picking the plain text that has been entered by, also the plain text that has been entered by the user, which has not been hashed. And it's looking at, what I'm doing here is that I'm checking whether the plain text, which has been encrypted using the function below, whether it matches the hashed password that I had previously hashed up here. Yeah. So, and then here I've created some virtual fields. That normally happens when you have two passwords. When you are lighting the, or you are inputting the password. So normally what happens when you are inputting a password, some developers create another field. That other field, it's called confirm password. So that the confirm password actually looks whether the password looks the same. The passwords looks the same. So here in this user schema, I've created a virtual field that is underscore password, and it's supposed to look whether the passwords really match. And then I'm creating a salt using the UUID. It's a random ID generator, it uniquely generates ID. And then I'm hashing the password using the encrypted password. And then I'm getting the virtual password now. Yeah. So this one here below, it actually checks whether the password has been hashed, or whether they generally look the same. So in the database, this is the database that I have. This is the salt, which has which is different, which is randomly generated by the UUID. And then this is the password. This is the password that I have hashed. So when you are being authenticated, let's just see the authentication or sign up. So when you're posting your data, or when you're entering your data in your website, this will normally you just input a plain text, and then that plain text, now the magic happens here at the back end. Now so here now the password is hashed and stored in a database like this. Yeah. Like that. And then yeah, and then there is also another way of using cryptography, and that is mainly used in another use. Another use is whereby this data is also encrypted. That's another thing. Encryption works well when you want to. So when you want to authenticate users' email, or you want to know the validity of the user's email, normally what we do, we encrypt all this data and then send this data to this particular email. Like let me show you on Auth. So you sign up, sign up. So you sign up, you enter your. So basically what happens, you input your information here as a request body, and then and then this information is encrypted. So this information is encrypted and stored in a variable called token. So this token is actually what is sent to the user here. So this is an email, a function to send this particular data to you, so that when you this is an email activation link which is sent to you together with the URL of the website, and then the token. Now this is the information, and then it has an expiration period of like 9 minutes or 20 minutes, depending with the way the developer has actually limited the time. Some other account activation takes like for 1 day. So this token, when you click on it, it's activated, it's decoded. This particular token is decoded here now from this part is where now you decode this data, and then this data is stored into your into the database. So if you don't activate your email, or if you don't use that particular link to activate your data, then your details are not created. So that's a way that developers use to actually verify that this particular email belongs to somebody. Let me show you the length of that particular particular token. So this is the token I had previously generated, or I had previously sent a link to myself to create a new user, and this is the token. So generally this token contains all that information: your password. Remember, your password is still encrypted, and then the data that you have entered in this particular website, it's encrypted into a long text. So this text, because if somebody gets this text, they won't be able to know that this thing contains information about your this information. You see, this is the information that is contained. This is the information that is contained in this token. In this token, yeah. And then you send it, and then your account is activated. So that is it on ways how cryptography is used in Web 2, and we also have seen how cryptography is also used in Web 3. Yeah, so let's continue. Is there any question as we move on? Hello? 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 Hello?
Yeah, we are hearing you. We are hearing you.
Oh, okay. It's just
It's
that,
like Damaris has dropped off.
yeah, it's like yeah. So that's how basically a system works. And yeah, so we can continue on and see. So we saw the early forms of cryptography. That was the scissor shift cipher, and we had also talked about the hieroglyphs. So these ones are 400 years old, the 400 years ago. This one used the pictures. So this one used to use the pictures to represent words. This is what I was talking about, hieroglyphs that used pictures to represent words and messages. And then we had the scissor shift cipher. So it replaces characters by an offset or a shifting, an offset of 2. Then if like this, if it's a hello word, then there is an offset of 2. So improvement over time, we had the stenograph and V coding. And then we have the modern cryptography. So what we talked about yesterday were modern cryptography. It's used of it's really means digital, and also it's much more of mathematical oriented, and it uses bits. So as I have said, computer represents data in forms of bits and binary codes. And binary bits, that is ones and zeros, and that's why if you have done a little bit of computer, you will know about octodecimals and hexadecimal, like the ones I was explaining yesterday. Then we have use of public key and secret key. That was asymmetric cryptography. And then this most of these algorithms are public, and even if they are public, it's impossible to actually obtain the original information from what you have seen with the token that is encrypted. So these are more terms on cryptography. So we had the plain text, the original information. We have the cipher, is the secret way of writing an algorithm. And then we have encryption key. It's a value that is used to encrypt the plain text. So yeah. And then we have decryption key. It's a value that is used to decrypt a cipher text. And then a cipher text is the encrypted information. Algorithm often is a public algorithm that uses key to encrypt or decrypt any information. So interceptors or attackers, these are what I was talking about yesterday about Eve, who is a person who is if is dropping. So it's an authorized entity that tries to determine the cipher text. Sometimes they are also called hackers. And under hackers, we have different types of hacker. We have the white hat and the gray hat and black hat. Yeah. And we also have the red hats or something. It's an organization. So we have the good hat, we have the good guys, we have the bad guys, and we have the in between. Those are the gray hats. So we have symmetric. Symmetric is a single key used for encryption, and then asymmetric is the use of two public key. Not two public key, but uses public and private key. So these ones we have already seen the works of symmetric and asymmetric cryptography, and the hash function. So we have the ecosystem. So I've actually shown you how generally things worked today in different websites. So in place of this, if we go back to the system that I was sharing with you, for the users. So in place of this would be like maybe MD5 or something else, or another form of encryption. I don't know whether this crypt library offers that, but what I'm sure is that I've always used this for my development, for hashing my passwords, which is a bit secure. But other websites like other website, the normal PHP websites normally used MD5, and which is a little bit weaker. So yeah, we will see how attackers do and how they actually get hold of certain information. So this is how encryption looks like. So the sender or the user at the end of the other side writes their plain text, and then there is an algorithm that does the encryption, and then that text is sent to the receiver, who has a decryption algorithm. Then they are able to see the plain text using the private key, so to decrypt. It's the same way email works. The email encryption are also done the same with yeah. So these are some of the common attacks that happen in cryptography. And one of it is the passive attack, simply gaining unauthorized access to information. And most common passwords. That's why people, when you are creating a website, or not an account using a particular website, you generally don't need to like repeat your passwords. So use different passwords, because there are people who have the ability to like predict the password that is normally used in websites. So most people actually use the 1 2 3 4 5 6 all password as password. Yeah, there are people who use password as password, and then there are those also who use it to they use password 1 2 3 Others use 123 password. So those are passwords that are easy to actually predict, and you can actually, if you stay with somebody. And others use password passwords of their pets. They use pets as their password. Like if you have a dog called Tom, you use the Tom 123 or something. And then others use their date of birth. Those who use date of birth, and also others who use their phone number as a. So that is passive attacks. And actually this is a common attack, because if you are a malicious person, and if you stay with your with your friend, and you are able to like predict the passwords they normally use. So sometimes for me, I normally change my passwords on like after 5 months, especially for my laptop. For my laptop, I normally change it after maybe 5 months. I change the password. Yeah, or I use a stronger password instead of changing. So active attack is a hacker attempts to make changes to data on the target or data and loot. So these sometimes people masquerading. Hackers pretend to be someone. Normally in crypto world, people pretend to be an organization. People are pretending to be an organization. There are those who are pretending to be CEOs of a particular organization, and then they ask you for details. So from the previous wallets that I mentioned, most of those companies don't actually request for your passwords or your private key. They never ask, and they don't have a help desk or a support desk. They don't have a support desk, and that is a good thing, because if you lose your key, you lose them. They won't be able to like uh, help you with that. Then we have the DDoS. This one we saw it under the Ethereum blockchain for under the smart contract. So denial of service is deny access to legitimate users by overwhelming the system. This one is common. So there are people who just want the system to go down, or some of them they don't know that they are jamming the system. So they send a request, multiple requests. Like if you are trying to sign up, they send a multiple request. Yeah, they send multiple requests onto a system when they are trying to create an account. So most sometimes you have to wait. If you try sending a request to the server, and then you see the server is taking too long to respond. Some of the things that you may do is that you check your internet connection before you start sending another request. You can actually call for support and see why. But some of these attacks happen because there is a particular hacker. They can create like a bot, and that is how some of the exchanges are actually hacked. Somebody creates a bot that is requesting for multiple orders, multiple orders. So the app continues looping and looping and looping and creating requests. And before they know it, the system has been kind of jammed. And yeah. So using technical information to steal user ID, using session IDs. So basically, when you log into a website, you are given a session, and that session is it has an expiration period, like 9 minutes, 3 minutes, and it's good advice for developers who are creating websites or creating systems to do timing. And currently these days, if you try to, there is a way you can be able to log into your web WhatsApp, also to your Telegram WhatsApp, Telegram web. And what they have done is that they have created a session. So if there is internet loss or you have lost, they will actually ask you whether this is you who is trying to log into to the web browser. So some people steal these sessions which are created by the developer. And these sessions ID, you are normally given a session ID when you log in, and that identifies that this is Ambrose who has logged in into this particular website. And they have actually advanced with modern technology. They have been able to advance, and they actually know which device you have logged in with, and your location, also your location, so that you can also be also on your side, you can be able to verify. So like 2 to 3 years ago in 2018, there was a person who actually logged into my, not 2019, but yeah, that was in 2019. There was a person who logged into my Instagram account in he kind of hijacked my session or hacked my IG, and I was able to, like, no, I saw him posting some weird stuffs on my page, and then I was like, this is not me. Then I went to the settings, and I was able to see that the device that logged in, and the location that this particular device logged in from, and it was in I think it was in New York. The device was in New York, and it was a Windows. It was a Windows. So I was able to, like, remove it from the currently logged in device, and I was able to reclaim back my account. uh, I was able to, like, mitigate the problem. Yeah. So that's an example of how session IDs are stolen and how password are hacked.
Does it mean that you use a weak password there?
Yeah, probably.
Because
I normally don't.
maybe
Yeah, I normally don't log into Instagram. I normally don't log into Instagram. Like in those days, Instagram, the app had no, it never had a lot of meaning to me, but the password was weak, so I had to change the password and everything, and you know, yeah. But yeah, that's
because be-
it.
because that is it. Because since like now,
Mhm.
one is getting people use password 1 2 3 4 5 6.
Yeah.
So you can just imagine. I'm not an hacker, but
Mhm.
I can just try in somebody's account and he enter. Oh,
Yeah, yeah, yeah,
before so that's just it. They just try some things. Okay, let me see. Password pass 1 2 3.
yeah,
Okay, and like that. So I think from this is for one to have a very strong password.
yeah.
At least before somebody gets a strong password, then that guy must be a confirmed hacker from birth. you know.
Yeah,
It's okay.
so it's something which is really bad, especially if you're a high profile. Like I don't know whether it was last year uh, when most high profile guys Twitter account were hacked. Yeah, it was last year. Last year Twitter was hacked. So Elon Musk Twitter account was hacked. Bill Gates, those guys, those high profile guys, most of their Twitter accounts were hacked. And something happening to such a company, like such a hack happening, it's nearly to impossible, because some of these attacks are perpetrated by people who are working, and that's actually what turned out to be. Yeah. So you also need to, if you're an organization or if you're a company, you also need to know the type of the type of guys you are working with. You have to, like, set uh good policies on people who do malicious intent into your company. Yeah, it's something which is really, cryptography is something which is really awesome. Yeah. So these are some of the other methods of some of actually we have somehow covered some of them. We continue with the methods of active attacks. So another one is whereby non-plain text attack, or KPA. So attackers know plain text of some part of the cipher text and attempts to decrypt the rest of it. So yeah, so maybe you have seen me type my password. You have seen me type my password. Let's say you have always seen me type specific keys on my password, and then you try now to like decrypt the rest of my password. Normally, this happens when you when you have done an extensive research about a particular person or a particular company, or you have eavesdrop in their email and you have seen some of the text. Yeah, then there is chosen plain text attack. Attacker has cipher text and plain text, and then attempts to determine the key of those particular message. Then we have this one. I mentioned it. I think on Tuesday. Yeah, on Tuesday or yesterday. On Tuesday or on Monday. The brute force attack, or the BFA. So this is the most common one. We have companies or a group of hackers known as the Fancy Bear. Fancy Bear actually use this method of attack to actually attack a website or something. So in this kind of attack, attackers try to determine key by attempting all possible values, and that's why it's called brute force attack. So it's like trying to knock down the door with a hammer and everything. Yeah. So you come with a jackhammer or a hammer or something, so that you can break that door down. So you're coming with all tools to just do that. Then we have man in the middle, or MI. Simple but technically challenging method of duping both the sender and the receiver into thinking keys came from the correct source. Yeah. So mainly this somehow this one this one occurs if there is a source whereby if there is you normally have a place where you kind of your data is encrypted. Yeah. If for example, if the email is supposed to be coming from google.com, the email is supposed to be coming from Google servers, uh, and then the other email is supposed the email are supposed to be going through the Google servers being encrypted, and then again coming out from the Google servers being encrypted. So the man in the middle will come in there and like send you an email pretending that the email is coming from the Google server, and the other one will send another email to the receiver saying that the keys are coming from the Google servers. Then we have side channel attacks, or SCA. It's data remnants, leading data that should have been deleted, and row hammer. So this one is a row level memory hack. And then we have flout analysis, forcing errors and reading output for crews. So forcing errors and reading out for crew. This normally happens with what we call SQL injections. And also there is what we call NoSQL injections. So you need to like come up with a good way that you are able. So I've actually had I had an example to show you. I don't know whether I still have the method. So like this one for signing, I may have the email of the user, but there is a sample code that is used that actually if you set it here, you're supposed to get a response here here on an error code. If I input a long message, the wrong password, the wrong password. If I input the wrong password, I'll be forcing out errors. If I do another one and another one, then there are some codes that I can either input here or as an input here when I'm doing a NoSQL injection, because I'm using MongoDB for this particular application. So if if I add there is a simple code. There is a simple code that you can add in this, either the email field or the password field, and then you will be looking for vulnerabilities in the database or in the system, whether this developer has actually done that. So now you are trying to force out errors or see whether this system has vulnerabilities. So you are forcing out to see if this particular system has vulnerabilities. You're checking out to see if this system has vulnerability when you're doing the fault analysis. Some of these fault analysis, there are people who do that for a living. The good guys, they normally do fault analysis. They analyze your system and tell you where there is a problem. And yeah, so we have another one, and that is towards modern ciphers, and or the difference between traditional and modern ciphers. So traditionally, ciphers were single characters, like the cipher, the Caesar cipher, which is shift a single character. And then we have two character cipher, prefair, uses two characters as key. Then we have the string cipher, it uses a string of words as key. This one, I think I mentioned it. I wasn't remembering the name. It was the one-time pad. So this one uses a key length equal one-time pad. Let me show you the picture. It actually looks like Telegram or something. Not the Telegram app, but the Telegram machine used in those days. So images. This is the one-time pad. Let's see. Oh, okay. Internet is. Yeah. So this is the one-time pad. And these days it's actually one-time pad or one-time password. It's, yeah, that's the other name of the one-time code or the one-time password or the OTP. You've actually seen this one in most mobile apps. It's generally like 6 letters or six words, not 6 words, but 6 letters that you are given as authentication. So for people who have had something to do with what do we call it? What do we call it? Exchanges. Yeah. So for those who have dealt with exchanges, to log into an exchange, you are always there is always an OTP code which is generated like like 75 or 75035, which is six letters separated. There sometimes you can find it's a code like this one, and it's given once, and it's secure because it's sent to your email. So for your those are some of the things which are being used as modern. Then we have this one, Telegram. I don't know, device. Yeah, this one also was used as an encryption method for like sending information in military, and yeah. So they would use like some sounds that was Morse code, something, yeah, maybe like 2 sounds to mean a B, 3 sounds to mean a C. Yeah. So when you hear those sounds, you wouldn't be able to know what the message they are communicating. Yeah. So that is the OTP, or one-time password. These days called one-time password. Then we have block stroke streams. This is the DES and AES. Printed is processed in blocks or streams of bits at a time. And then this is now the block cipher. So you have an input which has been encrypted, and then the cipher block, then encrypted text, and then more blocks. So they go on and on and on and on and on, creating a block cipher. And then we have Fiesta block cipher. So underlying model for many block cipher, same algorithm for encryption and decryption. The step is one, you input is split into 2 halves. The RHS input is transferred by function of which receives a sub key, and then the LHS, that is the right hash, the right and the left. They combined with transformed input from RHS using and then they are now combined together. So the process is repeated, and then this is the structure, the way it looks like. So this is the left side, and this is the other side, and then they are actually interchanged and then create the other one. Yeah. So this is the process, a flow diagram to explaining how this whole process does. Then we have data encryption standard, or the DES. The block size is 64 bits. The key length is also 64 bits, even though it's only represent like 56 characters or 56 bits. So loud key generated creates 48 bit key. It's a very strong cipher, fallen out of favor because small key value can be hacked with exhaustive search. So yeah, let me show you something. There is this particular website. I normally use it to. It's called. Remember it. It's a site. Site. It's a site that I normally use. Can't remember the I don't remember the site. I haven't actually checked. Oh, exploit, or let's called exploit. It's exploit DB. So exploit DB is a website to actually see the vulnerabilities of different languages and the type of let's see exploits. So this one you can search here. Okay. So you can actually cite, supposed to search. So you can use this website. Haven't used it in a while. PHP. Let's just do node. So you can cite, you can not cite, but you can actually search for. You can actually search for these are training. You can actually search for ASP. You can actually search for different languages and maybe even ports. And let's see if we can get one for PHP. So that you are able to know the statistics, or you can also get the statistics of the exploits of different languages. So if you are looking for developing your project and you are looking into getting into development, you need to see which language has which is secure enough, which has a lot of tools and securities. Because for PHP, if you are creating an application on PHP, I wouldn't recommend, because PHP has a lot of exploit. It's vulnerable to exploit and such. But for something like Node.js and advanced languages or high-level languages, they are much better when it comes to security. When it comes to security, that's on the side note. And so we have another form of DES. This one, data encryption standard. It's a triple one. So do not don't. It's the first one which has been changed in usage. Just a simple improvement on it. So effectively uses 3 key. So from this one was using 64 bits, but they have added other 3 keys. That was now making them 168 bits. So problem of short key solved. It's kind of slow. The process of encryption, that is encrypt plain text using K1, and then decrypt output of step 1 using K2, and encrypt output of step using K3. Then the output of step 3 is the cipher, and decrypt is decrypt in reverse order. So you first get this one and then the same way. So we have the advanced encryption standard, AES. So the more popular algorithm, the more popular algorithm today, and much faster than triple DES, uses 128-bit data, and Key size depends on the number of routes, a bit more complex algorithm. Yeah. So for details, see the online resources. So to date, no attack against AES have ever been successful. So complex website or cloud computing. Some of the cloud computing providers or cloud providers, some of them use this AES. Yeah. Then this one we actually saw. This is the public key encryption and we asymmetric key cryptography. So we saw how it works. And then it's more explained into details. And then we talked about the hash function. So functions that convert arbitrarily long numeric input into a fixed numeric output are called a hash. It's very efficient. It's hard to reverse the values, hard to produce same hash for different inputs. Some well-known hash functions are the MD. So it's a big range of hash functions that is from MD2, MD5, all the way to secure hash, and also the RPEMD. So most common use is in password storage. Sorry. So the common use of this hash function is in password and also in we saw it in blockchain. So secure apps will not save your password in plain text. People who do save plain text are people who have malicious intent. Like what if people like what happened this year there was a woman who had created something called Amazon Web Workers. That woman is don't know what I can say, but yeah, this is the armor.
She's a genius.
Amazon Web
She's a genius.
Workers. Yeah, but later on he was arrested. So this one, it's a long story. You can actually check it out. It was a Ponzi scheme, and this guy was this woman lipped people, a lot of people money. So he created a website claiming that he was offering people Amazon people work to work in Amazon. And a lot of people entered, and people are also required to like enter their credit card. So when you're entering your credit card, well, it was a long well, I'm telling you that hackers and scammers are catching up with technology. They are catching up with technology, and for you to actually the website was actually I don't know if I can get the search again. Okay, let me see if I can get the search again. So the website, it was actually an Android app. It was actually an Android app. People were forced to download it. Don't know if you can be able to see how the app looked like. Yeah, this is the woman. The woman who did that. So these are what I was calling. I was actually talking about. People masquerading to be an organization or something. Yeah, yeah. So for most secure apps, they will not store your password in plain text. It should be hashed, and they shouldn't be able to know. So once I've hashed in my system, once I've hashed those passwords, I cannot be able to like now know how to like go back to this, because remember I'm also using a secure hash algorithm one. Yeah. So that's it on the hash function, and yeah, we also learned on how it's used in blockchain, in hashing blocks, or yeah, in hashing the blocks and linking them together in a chain. Yeah. So these are digital signatures. Yesterday I showed you a digital signature or a digital certificate for website in cPanels. So how can we? So a question arises, and how can we be sure that a message is authentic? So in olden days, people used to like sign and put a stamp on a letter. There was a king's stamp. There was a king stamp. There was a king signature. There was also in terms of currency, there was a currency signature that was signed by the president. Or even nowadays, the to know the authenticity of a currency, there must be the CEO of the central bank's manager signature, and the president's signature, and then a serial number. So that's how people used to know that this letter or this currency actually belonged to this particular country, and they were able to tell the authenticity of that message. So in digital world, you need digital signatures to do the same thing. They ensure that the message is from the original sender with the original message. It also adds trust when exchanging data, and using encryption with digital signature is important. So for blockchain, we have seen it. So you actually need a signature so that to verify that this token is an Ethereum token, and this token was actually sent by Ambrose or Downways. So using encryption with digital signature is very important. It certifies authority responsible for management of the certificate, generating, issuing, and publishing, and also verifying, and also you can be able to like revoke those digital signatures. So an example where digital signatures are used is in emails. So we have encryption of an email, the process it goes through. So we have the message body captured, the message that you write, and then the message is hash calculated. Then the sender's private key is retrieved. Recipient public key is retrieved, and then hash value encrypted with sender's private key. And then the encrypted hash value is appended to the public key, so with a one-time session key, and then a one-time session key is generated, or kind of an OTP or something. Then the message body is encrypted with the session key. The session key is encrypted with recipient public key. Then the session appended to the encrypted message, and then the message is sent. So the same process happens. So you have to decrypt it the same. So this is the client, and this is the private key in implementation of all encryption. So we have the first step, second step, third step, fourth, yeah, and then you get a decrypted hash compared with the calculated hash, and then signed message is validated. So that's how the the email happens. So for the user's side, we are not like able to know what has happened. We just get our emails. Yeah, we just get our emails without knowing the 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 back of on how things are functioning. Just like the way we normally buy cars, we don't know. We only know that that car has a V8 engine, but we don't know how the pistons works, or how all the mechanism works. But we know that there is a V8 engine there. So in this session, we have been able to like know how this encryption and cryptography works and how it helps secure our data, whether may it in blockchain or may it be in the Web 2 or in the Web 2 application, that is the WhatsApp chat, the Telegram chats, because these messages are encrypted. Yeah. So there was a there was a there was a what do we call it? There was a question or a concern that was there before that WhatsApp Messenger or had a the company was able to like learn or see messages of people, and that is the problem with centralized application, because you don't have trust over, you have to have trust in brands, like you have to trust the brand, and you have to trust the person in that central organization, that they will actually do their due diligence to actually safeguard your your messages, to actually not sell your data. So those are some of the questions. Those are some of the questions that are now currently being asked by people. Is our data secure? Is our information secure? And people are actually getting to, there is this application, it's just my own view, whereby in China, it's an application in China, and it's similar to WhatsApp. And this application has gone to another level, whereby they are using the application to kind of have good citizenship, to do citizen rating, so whereby they rate you if you are a good citizen, if you have been doing some bad things, or what we call espionage or something. If you have done espionage, you can't access government services, you can't even get out of your country. So it's called a citizen rating, and it's something which is it works if you want to control masses, but if you want to give people freedom, just create something which is decentralized, which you don't use to like control how people think or how people view the things. Yeah. So those are some of the challenges that are in centralized applications. Yeah. We have also seen influences, people using centralized applications to actually influence voting, like what happened with Cambridge Analytica, and also the Twitter hack that happened during the US election. Yeah, during the US election, the recent election. uh, People were claiming that they that the any either of the presidential candidate was trying to use Twitter to influence elections. So those are some of the challenges when you use weak private key and decryption. And you see, if you create a system which is being used globally, and then it doesn't have security, then it's actually compromises a lot of people, even the entire company. Yeah, not the entire company, but the entire country. Yeah. So you have to be uh, keen when you are the type of encryption you are using. Yeah. So yeah. So yeah, actually, this is the next thing about the reason why most hacks are successful, and why most hackers are able to like get insider information. So one of them is user carelessness. user carelessness, and that actually also applies to your work ID. If you are careless with your work ID, then people who have malicious intent will always come and steal your credential and use them to get into your office or your home. Then we have stolen equipment. So hackers can steal your laptop, your phone, and yeah. Then we have incorrect implementation or backdoors. So this one I've explained in the NoSQL and no SQL injection and NoSQL injection. So you have to implement, or you have to create your system very well and implement the the coding standard well. And then we have like a backdoor, which hackers, not hackers, but programmers themselves. There are programmers who have a tendency of creating applications with a backdoor, so that they can let alone go and live off the company or something. So as a manager or a CTO in an organization, you need to like make sure that that developer does not leave a backdoor to a program. We have broken processes, all insider threats. So broken processes is whereby, and especially in corrupt, where there is corruption. So when you there is corruption which is involved in a certain organization. So let's say you are creating a user profile, and then you miss one process. So then that system, the process is broken. Is actually broken. It's like if you are looking to like get an admission in high school. So there is a process that is supposed to be followed, but if you add money or corruption in it, then the process is broken, because you get a direct admission. For insider threats, this is self-explanatory. Insider threats, these are people who know the system well, who know the compound, who know the software very well, or know the system very well, and they give out these credentials, and they start doing threatening the organization. So some of these insider threats are very very common, because you may have sensitive data, and these guys may have access to sensitive. If I don't know if you have watched something called a series called Mr. Robot. So if you're into tech, and that series will actually explain a lot of this hacking into detail. You will be able to see. So yeah. So Mr. Robot is somebody who works inside a company, and they are able to like perpetrate a lot of criminal uh, activities, and being inside the organization, and the management is not able to like know who is doing all this. Yeah. Then we have phishing attacks. So phishing attacks is whereby people fake the website, the original website, and they use it, especially for like what was happening with Amazon web service, Webworkers. It was an application, so you need to like enter your credit card details, your M-Pesa details, and then once you have done that, they have access to your credit card. So they dupe you that they make you think that this website is legit, it's the original one, and you input all your passwords, all your personal details, and then they are able to access your information, and later on get away with a lot of money from your accounts. So there have been such activities, especially I think it's in 2008 or 2009. there was the biggest ATM hack. This one was the biggest ATM ATM uh, ATM hack. I think ATM hack. So before here in Kenya, before so initially here in Kenya, or most countries in the world, I think in 2008, or from 20 I think. So what happened in Kenya? There was a time that the ATMs were not being printed they were not being printed by the banks. They were being printed outside the bank, and then you would be given like a like a 5 to 3 days waiting period, so that your ATM card can be processed and everything. So something happened all over the world, and the company or people who used to work for the ATMs to print those ATMs had people or insider threats. So there are people who are able to, like, and then the birth of what we call 3D printing. And the birth of 3D printing. So the birth of 3D printing actually give rise to these insider attacks, gave birth to this kind of insider attacks. So within that waiting period, what normally would happen, people working in those ATM printing in those companies that were printing ATMs would release the credit cards code or the credit card numbers, and then they would give them they would send them to the hackers, and then the hackers would 3D print the ATM cards. So before you go and pick your card, because already they would activate, they would be activated that particular day. So they had a way that they would be able to activate. So people were able to, like, that was in 2008, I think. People were able to, like, they were able to steal a lot of money in different countries, and that's when they decided that the banks should now be printing the ATM. As if you go there and you apply for your bank, and you create a bank account, then the ATMs are created there instantly without you having to wait for like 3 to 6 days. It's now instant. So, well, some problems are good because they require for urgent measures, and think of how we do our things. Yeah. Then we have another one is sending sensitive data over plain text. So sending sensitive data over plain text, this one is something which is common with sending data without actually encrypting that data is something that can fall into the long hands and can be used against you. Then we have the 0-day threats and the maintenance. So this is when the system is during in maintenance, and then somebody uh, uh, deploys a malicious code in in the system. So initially you won't be able to like know that there is a threat, but there is a threat because it has been upgraded together with the with the with the with the system while it's in maintenance mode. Then we have application vulnerabilities. So the application vulnerabilities goes together with bad implementation of code or poor code base using bad code. So this one is a common thing, like the way we saw the overflow and the entrance attack on the smart contract. Yeah, so those are some of the reasons why hackers are successful. And I've actually also talked about how you can be able to like mitigate these problems. So like I was saying, yes, we can have we can have we can have to create we can have to create security. Security is important. Yes, security is very important, but as much as we want to have security, there are such there are security measures that we can make even in our homes, which will literally somehow also lock us outside. So we also need uh, to use encryption or cryptography that is easy to use and easy for the users, so such that you don't lock people outside the outside their own homes. Yeah, for the case of like local cryptos, yes, the security is better there. The security is actually secure and everything, and nobody can actually hack the system, because the security is better, because they are using uh, the hash function. But at the same time, again, if you forget your password and if you lose your password, you are actually logged into you are actually logged to access your funds. Yeah. So yeah, you can create good programs that have good security and everything. Yeah. So that's it. That marks the end of cryptography. That marks the end of cryptography. So tomorrow I'll do a demo on how you can do Caesar cipher, the Caesar cipher, and also how you can be able to do an MD5. Yeah. So from this one, the final. So from this final, I've given an assignment on how you can write a simple encryption and decryption script using any language. So I'll show you using either JavaScript or Python. Then on the rest of your week, you can actually try and use the language that you are good with. Yeah, yeah. It's not a big script. It's a simple script. And then the other one is you can either download Trust or any wallet you have. I do know downloaders do have but for this particular class, you can use MetaMask. You can use MetaMask. So you can download Trust or MetaMask wallet and make or do a transaction on any token, and also share your hash function. Yeah, so you can use the test ethers that you got from the previous class, the one that you are able to like fund from the link based testnet. Yeah. So that is yeah, that is it on the assignment. Yeah. So tomorrow we will. There are some few things that I didn't talk about on the wallet. Apart from the script, I'll talk more about wallet disadvantages and advantages of different wallets. Yeah. Yeah. So I kind of mentioned. The consideration that you can make for wallet, and one of them is the security. Yeah. So basically, this class was more on how you can secure your assets and how the cryptography used. Yeah. So anyone who has a question as we uh, end this class. Yeah. Yeah. Anybody who has a question, concern, comment?
Yeah, from me, no question for now.
Okay.
No question. Sorry, the only observation I notice is that, are you hearing me?
Yes, I can hear you.
Like I downloaded the MetaMask, but it's not funded because my Twitter link, I cannot access Twitter here in Nigeria. You know the issue we are having with Twitter in Nigeria,
Oh,
and
okay.
I don't want to use the VPN to do that. So for now, my MetaMask doesn't have any value.
Okay. You can share your address, and actually you can both share your addresses so that I can fund your accounts with test ethers. With,
Okay, great.
yeah,
I'll
yeah.
do that after the class. I'll do that.
Okay,
Yeah,
okay,
thanks.
okay. Yeah. Uh, yeah. So Dominic says she's good, and yeah. So awesome. Yeah. I hope you enjoyed the class, and yeah. So bye, and have a good night.
And you too. Thank you very much. Have a good night.